In this paper, we propose a behavior authoring framework for animators to easily orchestrate complicated stories between multiple actors in a flexible manner with minimal specification. The scene shown here is automatically generated using our framework. The characters, vehicles, and even the traffic lights are actors that were authored. Specification begins by defining the state space, action space, and behaviors for actors in the scenario. Actions, such as a move action, are defined by specifying when the action is possible, the effect of the action, and the cost of executing the action. Behaviors define the goal and optimization criteria for an actor. We breathe life into a city block by populating it with 100 generic pedestrians with simple behaviors. They avoid collisions and stay on sidewalks due to simple constraints authored by the user. Other actors in the scene include vehicles or even abstract entities such as a traffic light. This traffic light influences how other actors interact at the intersection. For this scene, the traffic light is authored as a simple state machine that transitions over time. A defining feature of our authoring framework is the ability to specialize the simulation. End users only need to make minor additions to an existing specification in order to automatically generate different results. In this scene, the yellow actor is specialized to be an elderly man who moves slowly and follows his grandson. This is achieved by limiting his speed of movement and having him follow a target. When an accident happens, the grandson escorts his grandfather to safety. This behavior is generated by simply specializing the objective of the grandson to maximize his grandfather's safety. As a result of this crash, cautious pedestrians prefer to move away, while daring pedestrians find it interesting to explore the situation. This is achieved by specializing the cost of actions to indicate what actions are in an actor's best interest for a particular state. Cautious actors are authored by increasing the cost of actions that place them in danger. Daring actors are encouraged to take actions that place them in danger. The generated behavior is a result of optimizing the objective function of each actor. The crash itself was authored by defining a reckless vehicle that is specialized with a lower collision radius, ignoring signals, and moving at maximum speed. We also authored a constraint that two cars must collide somewhere in the auto-generated scenario. None of the results shown here are pre-scripted. The crash and the events that follow are all automatically generated using our framework. These firefighters collaborate to surround and extinguish the two fires because they are given a common goal. We also defined a thief specialized with a steal action whose goal is to make money. Initially, each vendor has a separate goal to ensure his money is not stolen. When the accident happens, the cautious vendors leave the scene of the explosion, leaving the vendor stand susceptible to the thief. Note that we did not script the thief to steal from the stand. Our framework generates the simulation by satisfying the competitive goals between the thief and vendors. In this first take, the thief successfully gets away. In a second take, we modified the vendor behavior so that they share a cooperative goal to keep their money. With only a few simple changes to the specialization, the vendors now work collectively to surround the thief as shown here.